Hello everyone, my name is Zeyu from Department of Computer Science, University of Maryland. Today we're presenting you our late break work towards on-the-wall tangible interaction using walls as interactive, dynamic, and responsive user interface. So why walls? Indeed, the walls are ubiquitous in indoor areas, but they're mostly used as structural foundations or used for hiding infrastructures. Maybe the other usage is as substrates for daily essentials like lights and switches and TVs, but we haven't really been using them for interactivities. However, we find that the walls are actually providing good opportunities to build TUIs on them. Firstly, we have large unused areas to work with, especially the higher up ones. And secondly, they're providing unique interaction channels that doesn't interfere with people's current activities indoor. And thirdly, as mentioned, there are a lot of fixtures on them. If we're managing to mobilize them, we can already create a whole new way of interacting with those surfaces. And lastly, we're not the first one to work on the TUIs, and there are a lot of excellent previous efforts that we can integrate onto the walls that can also create really fruitful interactivities. We would like to share our vision of the ultimate on-the-wall interaction and how they can benefit our lives, imagining if the technology is fully developed and mature. For example, a mobilized storage space that can utilize higher up areas without the users going up to them with a ladder, but they will come to the users upon summon. And for example, in classrooms, if we have 3D displays instead of 2D, they can help better explain ideas that are not so intuitively shown on 2D illustrations. And also we can have dynamic audio or lighting systems that can adapt to users' locations no matter where they are. There are so many more to go, but I'll stop here. To make the visions come true, we believe there are two most effective ways, and each has its own challenge, and we're detailing them in the paper. You can refer to that for more content, but mainly the two streams are to embed current existing TUI technologies into the wall or develop on-wall robotic system to make the on-wall fixtures dynamic. As an attempt to build one, we take one step forward with the robot idea and try to create an on-wall robot platform to provide dynamic indoor environments. And here's our design considerations. We want the robot to be able to stably climb on the wall with high payload that creates low noise level, and they are suitable and they have suitable size that blend into the indoor environments. And carrying these considerations, we designed our Climbot on, as you can see on the right hand side of the slides. Climbing mechanism is based on a set of motor-driven sticky threads as illustrated, and this mechanism will work on glass and comparatively smooth surfaces like painted walls. And the hardware is customized and 3D printed, and they are integrated with off-the-shelf motors and customized PCBs. And sticky threads are manufactured with custom mold rubber material off the shelf. We have the detailed process in the paper, but mainly we just mix them and mold them in 3D printed molds and laser cut them into shape. Here's a brief clip of our early prototype moving on the wall, and we briefly explored some application scenarios that we can achieve with our Climbbots, including provide adaptive lighting system and help turning on and off switch remotely on the wall. As mentioned, this is still an early stage of development, and a set of directions will also be explored for more complete system. For example, the in-situ turning that will enable more flexible moving paths and long-term deployment to save energy, and also multi-agent applications that will make the whole story more interesting. So that's so much for our vision and implementation. Thanks for listening, and now we're open for questions.